Okay, Year 11, some students have asked about exercise 811 and questions with two variables, and I'm going to look at particularly question 23, 24 and 25. So what do they say here? In question 23, if the volume of a cube is increasing at a rate of 23 millimeters per second, find the increase in its surface area when its side length is 140. So let's write down a few things straight away. The volume of this cube is s times s times s, s cubed. And let's get, hold on, let's turn that off. Let's get dv ds, which equals 3s squared. Now, I know that dv dt equals 23 millimeter cubes per second. Now the problem is, what I want is ds dt. I want to find how the side length is changing. I want to find the change in the side length with respect to time. Well, ds dt, that's going to equal ds dv times dv dt. And I know they're not fractions, but the dv's will cancel and I'll get what's left. Now, I have dv dt. I don't have dv ds. ds dv, but if I turn that upside down, I will get it. So, it equals 1 on 3s squared times 23. So I get ds dt is 23 on 3s squared. Now, I haven't really quite got there yet. The surface area, which I'm just going to call A to make it easier, the surface area of this cube is 6 times one side area, which is 6s squared. So 6s squared. So dA ds, hold on, dA ds, the derivative of that, is 12s. Now, what does the question want? The question wants, find the increase in its surface area, which is dA dt, which I don't have, the increase in the surface area when its side length is 2.1. Well, dA dt equals ds dt times dA ds. And I have both of those. So it's 23 on 3s squared times 12s. And that'll become 90. If I go here, 3 goes into that 4 times. 1s goes. So you get 4 times 23 for 8, 92, is that? 92? 92 on S. And that is the rate of change of the surface area with respect to time, but in terms of the side length. And they say, well, find that rate of change. So when S equals, what do they want? 140. So dA dt equals 92 on 140. And that's the rate of change of surface area with respect to time, which is 0.66 meters per, what are we doing area? Meters squared per second. Millimeters squared per second. So let's revise what we did. we had the rate of change of volume. So we had to find dV, or we had to find an equation for the volume. We differentiated the volume with the variable that we had, but we didn't want that. We wanted the rate of change of the side length with respect to time, and we got that. We wanted the rate of change of surface area with respect to time. So we found the rate of change of surface area with respect to the side length, and then multiplied these two things together using the chain rule to get the rate of change of the area with respect to time, which is what we needed, and the variable that we had was the side length. And that's pretty complicated. It requires a little bit of knowledge to be able to do that, and the more you do, the better you'll get at them. Let's have a look at question 23. Sorry, 24. So question 24. We've got a sphere. So again, I'll just create some space. I'll get rid of all this. And we'll look here at question 24. And what do I have? I have a sphere. Now, the surface area of a spherical bubble is increasing at a constant rate. Well, first thing, let's get the surface area. And the surface area is 4 pi r squared. And they're saying that the surface area is increasing at a constant rate of 1.9 millimeters per second. So I really should just call it dA. So I'm just going to get rid of that S because otherwise I'm going to have too many letters. So the surface area I'm just going to call A. And dA dt equals, what they say? 1.9 millimeters per second. Millimeters squared per second. Well, there's only one variable in this one, and it's the r. So let's find dA dr. That 2 is going to come down the front, and we're going to get 8 pi r. What do they want me to find? Find the increase in its volume. Find the increase in its volume when its when its radius is 0.6. So I'm going to do this a little bit quicker. So my volume equals 4/3 pi r cubed, and I'm going to find dV dr, and I'm going to get 4, I'm going to get the 3 times 4/3 pi r squared. Oh, look at that, 4 pi r squared. That's really, really interesting that the rate of change of the volume with respect to the radius is indeed the surface area. Righto, what do I want to find? I want to find the rate of change in volume when the radius. So I've got to find dV dt. The rate of change of volume, dV dt. I'm going to use a really long form of and I could do this in 2 steps like I did before, but I'm going to just do it in long form. I'm going to go, all right, dV dt, well, that's going to equal dV dr. I know they're not fractions, but they act like fractions, times dr dA times dA dt. And I know they're not fractions, but the dAs are going to cancel, the dRs are going to cancel. I'm going to get dV dt. Now, I currently don't have dr dA. I'm going to turn that one upside down. Again, it's not a fraction, but it works like fractions. So, dV dr, 4 pi r squared. Dr dA is 1 over 8 pi r. And dA dt is 1.9. Well, that 4 is going to cancel, that pi is going to cancel, and one of those r's is going to cancel. I'm going to get a 2 down there. So I'm going to get 1.9 R on 2. And it says, find the rate of change, find the rate of increase in its volume when its radius is 0.6. So when R equals 0.6, dV dt equals 1.9 times 0.6 over 2. And I'm not going to waste any time and go to the calculator because I did this earlier. 0.57, and it's millimeters cubed per second. Right, so I did that one a lot quicker, but again, we've got two variables there. What did we find? We had the surface area, and we derived the surface area with respect to R. We knew what the surface area was decreasing with respect to time. I could have found dr dt and then whacked it in here, but I just did it all in one go. Over here I did the volume, and I found dVdr, and then I just put it all together. Okay, let's have a go at question 25. I'm just finding where I did it earlier, because these are quite difficult. You need to make sure, was it 25? 23, 22, oh, here it is. Righto. So let's have a look at this one. Question 25. A rectangular block of ice, and they've drawn a diagram for us, but I'm going to draw it here anyway. A rectangular block of ice with a square base. I had to say that after I've drawn it. I'm going to learn to read. With a square base. So a square base prism. So that's S, and that's S. Has a height half of the side base. Well, I've drawn this terribly wrong, so I'm going to do this again. So I've got this square base, and that's S, and that's S, and that's S over 2. A rectangular block of ice has a square base. Well, their picture of that ice block is nowhere near right. Half the side. As it melts, the volume of the block of ice is decreasing at a rate of 12 centimetre cubed per second. Find the rate of change. Well, let's find the rate of change of the surface area. So let's find the volume, and it's S times S times S on 2, which is S cubed on 2. Let's find dV ds, and that gives me 3S squared on 2. I already know that the volume is decreasing, so dV dt. Now remember, this is decreasing, so I have to put a negative 12, and what are we in? Centimetres? Centimetres cubed per second. I also need the area, the surface area. I'm just going to call it A. I don't want to put the S in there because it'll give me too many letters. And the surface area, well, I've got the front, which is S squared, and I've got the back, which is S squared, so I've got 2S squared. And then I've got those 4 rectangles around the centre. So here, down that side, down and along the bottom. And they're all S times S on 2. So there's 4 of them. So plus 4 of those of S times S on 2, which gives me 2S squared plus 2s squared, which is 4s squared. Now, dA ds equals 8s. Now, what have I got to try and find? I've got to find the rate at which the surface area will be decreasing. So I want to find dA dt. So dA dt. Now, what have I got? I've got dV ds, but I'm going to want those to cancel. So I'm going to need ds dV. I know they're not fractions. dV dt. Two dV's will cancel. I'll have ds dt. And I want dA dt, so I'm going to have dA ds. And the s's will cancel, give me dA dt. So I have to turn this one upside down. So I get 2 on 3s squared. What's dV dt? Negative 12 centimeters cubed per second. And what's dA ds? 8s. Now let's get some things out of here. 3 goes into that 4 times, and one of the s's goes. So in the end, I'm going to get 2 times 4 is 8, 8 times 8, negative 64 on s. Now, when s equals 2.1 centimeters, the area is decreasing, and that's what the negative tells you, negative 64 on 2.1, negative 30.48, and its area, centimeters squared per second. That's what it's going down by. Now I'm just going to check that answer because I've got the work solutions on the other computer. And 25. Yeah, righto. So it's decreasing at 30 point. That's what the negative tells you, that it's decreasing. So hopefully you're able to do those and now see how I've done them. I'm looking, yeah, they do it in the textbook the same way that I do. Good luck.